Hello. Now this is chapter 4, line, surface and volume integrals, and in this part I will talk about line integral. So line integrals is defined as any integral which is to be evaluated along a curve. So we calculate this integral over a curved path, over a curved line, and line integrals can be defined in terms of limits of sum as are the integrals of ordinary calculus. So integral of the type you can see over here, this is limit a to b vector a dot tl and integral a to b vector a cross tl and integral limit a to b phi dl. So there are some types of integrals and their examples of line integrals which are evaluated from the point A to B on some specified curve. In first case, each element of dl, you can see here, each element of dl on the curve is multiplied by the local value of A scalarly. So according to scalar or dot product rule, then these products are summed to get the value of the integral. So suppose a vector A, in the space and AB a curve from point A to B, from point A to B. If the curve AB is subdivided, we are just dividing this curve AB into infinitesimally small vectors element dl1, dl2, dl3 and so on dlr, and scalar products of vector a1 dot dl1 and a2 dl2, a3 dot dl3 and so on ar dlr are taken where the vector a1, a2, a3 are the value of vector field A at the junction points of vector elements dl1, dl2, dl3 and dlr. Then sum of these products these products are a1 dl, a2 dl2, a3 dl3. You can write it in, you just sum of all these, just take summation limit a to b ar dl r equal to integration a to b vector a dl. You can consider this equation 1 along the entire length of the curve is known as line integral of a along along the curve AB. So line integral from point B to A will be negative. This is very important to be note. Line integral from point B to A will be negative. To that from A to B. And line integral in Cartesian coordinate can be represented as line integral in terms of Cartesian coordinates can be represented in terms of Cartesian coordinates can be represented as integration A to B A dot dl is equal to integration A B. Just put the vector in Cartesian form ax dx plus ay dy plus az dz. So if A represent force on a particle moving along the curve AB, then the line integral of f over the path described by the particle represent the work done. So this work done will be a force actually. W is, this work done is limitation A to B F dot TL. So line integral around a closed curve. You just consider any closed curve. This is X and this is Y. This is point A and this is point P. So line integral along this closed curve denoted by line integral sign with a circle over it. So this is a integral over a closed surface which is denoted by this circle on the integration sign A dot TL. The circle on the integral sign indicate that the path is closed. If the line integral around any closed path is 0, that is phi A dot dl is equal to 0, that means the vector field is said to be conservative. So there exists a definite connection between the line integral in a plane and curl of a vector field. So this is the line integral. In next part I will talk about surface integrals. Thank you.